Hi, my name is Yufeng Guo, and today we're going to look at how TensorFlow Enterprise, or TFE, builds on TensorFlow to enable the seamless creation of production machine learning applications with enterprise-grade support through the power of Google Cloud. To learn about the benefits of TFE, let's imagine a scenario where a data scientist visits an ops team to ask for help productionizing their machine learning platform. The question then becomes whether there's a suitable platform for both experimentation and production. TensorFlow Enterprise is ideal for this kind of situation. Google Cloud has your solution to productionize your TensorFlow applications. As part of Google Cloud, TFE provides managed services, cloud-scale performance, and enterprise-grade support. Let's start with managed services and check back in to see how our data science and ops teams are doing. The data science team needs development environments with lots of compute power, and in an on-prem non-managed system, the burden of setting them up often falls to the ops team. There are many challenges to operating this way. Machines with GPUs are expensive and take a long time to acquire. Software installation and management consume significant time. Additionally, there's the problem of over-provisioning. This kind of non-managed ML platform doesn't scale for enterprise production projects. One solution to these constraints is to introduce a standardized ML platform for the data scientists and ops teams to solve these problems. Enter TensorFlow Enterprise on the Deep Learning VM, or DLVM. The DLVM is a standardized VM image for machine learning applications. TFE currently supports TensorFlow 1.15 and 2. The machine comes pre-installed with the everyday tools for data scientists, including CUDA drivers, NumPy, sklearn, pandas, and of course, Jupyter. Since it's a standardized software stack, it's easily manageable by ops engineers. The DLVM is deployable to Google Cloud with Google Compute Engine or AI Platform notebooks in just a few minutes. Also, there's no over-provisioning problem because you only pay for the resources you actually use minute by minute. Let's take a look at how you can actually create a GCE instance with the DLVM image. In the GCP console, head on over to the Compute Engine's VM Instances page and click Create. Select Marketplace from the left-hand menu and type Deep Learning VM in the search bar. Select the Deep Learning VM and click Launch. In this menu, you can select your machine type and if you want GPUs. You can also select the TensorFlow Enterprise versions 1.15 and 2. For now, let's choose TensorFlow 1.15 without GPUs and just one CPU, a very simple image, and just click Deploy. The manageability you just saw increases the portability and scalability that you just can't get with local notebooks. There's often a huge gap between proof-of-concept notebooks and production machine learning code. For example, notebooks are often particular to the local environment of each data scientist, but production code should be portable and shareable. A single notebook instance can't serve 10 million users. The ops teams have to take on a lot of work to scale and load balance to build a production system. Proof of concepts are manually deployed, whereas in production, the ops team needs to manage a reproducible end-to-end lifecycle. And after all of that, continuous monitoring and alerting still need to be taken into consideration. One way to fill the gap between experimentation and production is deep learning containers, or DLC, with TensorFlow Enterprise. DLC provides the exact same standardized ML software stack as a DLVM, with support for TensorFlow 1.15 and 2, as well as lots of common data science libraries, but now it's on a portable and scalable container image. If your data science team is already using DLVMs, then it's much easier for ops engineers to migrate their code to DLC and deploy it to Google Cloud services such as AI Platform and Kubernetes Engine. With deep learning containers, the ops team won't have to add 100,000 lines of code to make a robust system. For example, if you use AI Platform or Kubernetes Engine to run the container, you automatically get the benefits from the managed service, such as container scheduling and lifecycle management, scaling out, load balancing and failover, logging and monitoring, troubleshooting, security, and more. Now let's see how scale cloud performance of TensorFlow Enterprise can benefit you. In many cases, data scientists tend to use smaller, sampled datasets for building their machine learning models and don't bother handling the raw big data. So it falls to the ops team to design an ML pipeline that can accommodate the 10 million rows from storage without any I/O bottleneck and continuously and smoothly pre-process and train the model every day. Because TensorFlow Enterprise provides TensorFlow runtimes specifically designed for Google Cloud, you can fully utilize the cloud scale performance of both cloud storage and BigQuery with minimal changes to your existing TensorFlow code. Lastly, let's talk about enterprise-grade support. The pace of AI and software versions is evolving rapidly, and it's hard to keep up with new library versions always coming out. That is why TensorFlow Enterprise includes long-term support. For TensorFlow 1.15 and 2, Google Cloud will provide security patches and select bug fixes for up to 3 years. These versions will be available on Google Cloud, and all patches and bug fixes will also be available in the mainline TensorFlow repository. TensorFlow Enterprise is available today with support for TensorFlow 1.15 and 2. Speed up your software development and ensure the longevity and reliability of your AI applications and services with enterprise-grade support. It's the only offering from the same team that created TensorFlow. Head over to g.co/cloud/TensorFlow to get started today.